Hello guys, hope all of you are well. So in this video today we are looking at a practice paper from units 1 and 2. Unit 1 being all of your chapters on mechanics, which basically go all the way from physical quantities to the end, which is pressure, and unit 2, which is the entire unit on heat, starting with kinetic model of matter, then thermal properties of matter, and then culminating in the transfer of thermal energy. So there's an MCQ paper. It's also good prep considering that your MCQ paper is coming up. So let's have a look at it. So question number 1, the propeller on the board pushes water backward with a force of 2000 Newton. The board moves forward in the water against a total resistive force of 1800 Newtons. According to Newton's third law, what is the forward force on the propeller due to the water? So if you look at this question, you are given this resistive force which is backwards, force of propeller on the water which is also backwards, but the boat is moving forwards. And it says according to Newton's third law, what is the forward force on the propeller due to the water? So if this is Newton's third law, and if I have a good grip on this, I know that the force on the propeller due to the water would be equal and opposite due to the force on the water due to the propeller, right? And I do have that force of the propeller on the water. So propeller on water, and this is water on propeller. By Newton's third law, both of these would be equal and opposite, so it's going to be the same value of force, 2000 newtons, but this is the force which the propeller applies on the water, so water applies a 2000 newton force on the propeller, which is forwards. Question number 2, which instrument is used to measure the diameter of a sphere with a single measurement? So the answer to that is a micrometer, very straightforward. What is the reading on this micrometer? Again, if you guys recall, we have done this question previously as well. So I look at the main scale, so 5, 5.5, 6, 6.5. So this is 6.50 millimeters. And then I need to read the rotating or the thimble scale. So 10, 11, 12, 13. So you just add a point in front of this, so 0.13 mm. You just add both of these up, so this becomes 6.63, which is option B. Next, which statement is of Newton's third law of motion? Every force causes a reaction. Yes, but this is not clear enough, so let's see if we have something better in the later options. If there is no resultant force on the body, there is no acceleration. This is really a statement of Newton's first law. So this is really Newton's first, and in some way you can also say the second law. Forces acting on the body are always equal and opposite. May seem tempting as a correct answer, but this is wrong. Newton's third law says that if an object A applies a force on an object B, B applies an equal and opposite force on A. So it's not talking about the same body, it's talking about different objects. To every action there is an equal but opposite reaction. So between this and this, obviously this one sounds more sensible as an option. But in your most recent syllabus, you have to talk about Newton's third law in this way, that if an object A applies a force on B, so if A applies a force on B like this, F A on B, so B applies an equal and opposite force on A, right? This is how you have to write it. So both of these forces are equal. Question number 5, a car is brought to rest in 5 seconds from a speed of 10 meters per second. What is the average deceleration of the car? So it started out at 10, it was brought to rest. So final velocity is 0, u is 10, time is 5. So for the acceleration, v minus u over t, so 0 minus 10 over 5, which is minus 2 meter per second square. But because this says deceleration in the question already, I know that the negative sign has been considered beforehand, so it's just 2. Question 6, a skier is traveling downhill. The acceleration on hard snow is 4 meter per second square, and on soft snow it's 2 meter per second square. Which graph shows the motion of the skier when moving from the hard snow to the soft snow. So if I look at these options, all of these are speed time graphs. Now, having looked at this, I think about what I know of a speed time graph. So this is a speed time graph, first step. And then I think about the features. So the gradient here is the acceleration, and I also know the area is the distance, but it's not really going to be used in this question. So initially the acceleration is 4 meters per second square, so that's a higher value of acceleration on the hard snow. And then when it moves to the soft snow, it's still accelerating, but it has a lesser value. So what I'm really thinking about in this question is I first need to have a higher gradient, because this is a higher acceleration, and then I need to have a lower gradient because it has a lower acceleration. So I'm first looking for a steep section, which then turns into a less steep section, but it must still be going up. So if I look at these options, it obviously can't be A, it can't be B either, because both of these sections need to be going up, can't be going down, it's not decelerating. Then between C and D, I can see that in C, the initial portion is steeper, and then the next one is not as steep. So this is the correct one, right? So I didn't even have to look at the values here to talk about this. You could have also looked at the values. So here 10 over 5, rise over run is 2, whereas it should be 4 first and then 2. Question number 7, forces of 25 and 40 Newton act on the object in the direction shown. Which arrow shows the direction of the resultant force on the object? So for this purpose, you can just make a simple vector diagram and superpose one of these forces. So this is our 40 newtons, this is our 25 newtons. So if I just take this 25 Newton force and put it over here, so you know that the direction of the resultant force would be from the start of the first one, the head of the first one, the tail of the first one to the head of the last one. So this is the direction. So that looks like B, which is going to be my correct answer here. Question number 8, a particle P is moving in a horizontal circle about O. P moves at a constant speed V. Which statement is true? A force of constant magnitude is acting in the same direction as V. Is the force a constant magnitude? The answer is yes. For a uniform circular motion is what we really call it, because the radius is fixed, speed is also fixed. But does it act in the same direction as V? The answer is no. The force acts towards the center of the circle. So force of constant magnitude is acting towards O, correct. Force on P varies in size, wrong. There is no resultant force, wrong. Question number 9. The graph represents the movement of the body. So we have a speed time graph again. How far has the body moved after 5 seconds? So we just did a question where we were supposed to use this idea that the area under a speed time graph is distance. So I need all of this area, which as you can very clearly see is the area of a triangle. So the base of this triangle is 5. The height of this triangle is 10. So half base into height. So 5 times 5 is 25 meters. Question number 10. A player catches a ball of mass 150 grams moving at a rate of 20 meters per second. So this is really its speed. If the process of catching is to be completed in 0.1 seconds, what is the force exerted by the ball on the hands of the player? So first thing we should note is that this mass is in grams. It's not in kg. So it's not in our SI units. And this was previously moving at this speed of 20 meters per second, and we have to catch it. So we really have to bring it to rest. What is the force exerted by the ball on the hands of the player? So what we can use in this case is the definition of force, the rate of change of momentum. And if I can find this out, I can just divide by the time. So the mass here is 150 grams, so 0.15 kg. Final velocity is going to be 0 because it comes to rest upon catching. And the initial velocity was 0.15 times the initial speed, which is 20. And then you just divide by the time, which is 0.1 seconds. So this is really going to be 1.5 times 20, which is going to be 30 newtons. On to the next one. A bullet of mass 5 grams is fired from a gun of mass 5 kg. What is the velocity of the muzzle if the recoil velocity is 5 meters per second? So what is the velocity? And apologies, this is a typo. It should really be the velocity of the bullet if the recoil velocity is 5 meters per second, because the muzzle is part of the gun. So that's recoiling with this velocity. So here the idea is basically related to the last case of momentum that we did, which is that in this case, both of these would have equal and opposite momentums, right? So with this gun projecting the bullet outwards, it moves backwards with a speed of 5 meters per second. And we also know its mass. And we know that this bullet, what is going to be its speed of ejection here, right? So we know this mass as well, which is 5 grams. So both of these must have equal and opposite momentum. So the momentum of this is going to be backwards, this is going to be forwards. Even though it's not really required, but if you are somebody who likes to abide by rules, then it's nice to use the sign convention here as well. So let's do what we always do, is that we take velocities forwards as positive, velocities backwards as negative. So if I'm talking about the bullet here, I would say that previously, if everything is at rest, I would say that the momentum of the momentum before the collision is 0. Momentum after the collision is the momentum of the bullet plus the momentum of the gun. This is 5 grams, so 0.005. So this is the mass of the bullet, and its velocity is what we really need to find. And the mass of the gun is 5 kg. And this is moving backwards, so I'm going to put a negative sign here. So it's moving backwards with a velocity of 5. So I would have this equation 0.005 v equals to 25. And then I just need to make v the subject. So it should actually turn out to be 5,000 meters per second. That's the correct answer, which is not given here. So that's a typo on my side. Alright, question number 12. The total weight of the load and the wheelbarrow shown is 600 newtons. What is the size of force F needed to just lift the loaded wheelbarrow? So here the idea is that for it to just lift it, the anti-clockwise moment produced by F and the clockwise moment produced by the weight, they should be equal, right? So here is the pivot here. So you just need to make sure you take the distances between the force and the pivot. In this case, for the 600 force, it's going to be 600 times 70. And for the other one, it's going to be F, and it's going to be all of this distance, because that's the distance from the pivot. So F times 120. And from here, you just make F the subject of the equation. So this is what, 5, and 5 times 70 is 350 newtons. In moments, in O levels, the only thing the examiner will confuse you with, and that's really the only thing you have to be attentive about, is the distance of the force you're taking. So always make sure, and again trace it out with a pencil to make sure you always take the distance of the force from the pivot. Question number 13 then. Energy from the petrol is used to operate an engine. Engine drives a generator which produces electrical energy. What is the overall efficiency of the process? So this is the first input, this is then the work done, and this is finally the output. So efficiency by definition is output over input. I have 100 joules of output given a input of 400. So I just multiply this by 100%, which should turn out to be 25%. Right? Output over input. A piece of uniform card is suspended freely from a horizontal pin. Which point is called the center of mass? So here, this is very obviously an irregular object. So you need to look at this object and think about what the possible center of mass or the center of gravity could be. So because this is wider at the bottom, it's slightly going to be shifted towards the bottom part. So it obviously can't be D, because that's right on the edge If you remember the ideas of center of mass, so this is like an average of all the masses that make up this object. So it's probably going to be either B or C, can't be A, can't be D. Both of these are way too much on the edge. But then it should really be C because more of the mass is focused here rather than here. So for this one, it's going to be C. On to 15. A crane lifts a load of 1000 Newton through a vertical height of 3 meters in 10 seconds. Input power is 500 watts. What is the efficiency of the crane? So given the weight here, which is really mg, and given the height here, and given the time here, I can find out the gravitational potential energy gained. How do I know it's gravitational potential energy? Because of this word. It's the vertical height which it gains, and dividing that by the time is going to give me the output power. So let's first do that. So output power would be the energy over time. So mgh is the formula. Mg is given as 1000, the weight, times the height, which is 3, divided by the time, which is 10. So this turns out to be 300 watts as the output. Again, for efficiency, I use output over input and times 100, just because the question has percentages given. So this is going to be 60%. So on to the next one. So forces are applied to a beam, a uniform beam pivoted at its center. What does this mean? This means that for all of these beams, the center of gravity is at the center, or what you may also call as the center of the mass. And because it's also pivoted here, the weight of the beam itself does not play any role here. Which beam is balanced? So for balance or for equilibrium, we know there are two conditions, the resultant force being 0 and the resultant moment being 0. We can't really use the first one here, the resultant force being 0, because we do not know of the force which the pivot applies on the beam. So we can only really work with the second condition. So here, this looks like both of these forces do produce equal moments. That is true. But both of these, if I just trace around these forces, both of these produce clockwise moments. So A is definitely wrong. What about B? So both of these do produce anti-clockwise and clockwise moments. So potentially they could cancel out. But if the forces are the same, and if distances are not equal, then their moments cannot cancel out completely here. So this option is also out, right? If this was maybe at a distance of 0.2 meters, then it needed to have twice as much of a force because the distance is half. So while I'm talking about this, I'm really using this relationship, right? For it to have the same force as whatever this was producing. So if it has half the distance, it should be twice the force for the moments to be equal. Part C, again, both of these are producing the same direction of moment. Both of these are clockwise, which is wrong. So it must be D then. And let's also see why. So if you do this here, 5 times 0.4 and 0.2 times 10, both of these will be equal to 2 Newton meter. And one of these is anti-clockwise, the other one is clockwise. So this is exactly what we're looking for. Question number 17. Two men jump out of the airplane at the same time. One of the man opens his parachutes and the other two men remain in free fall. Why is the man in free fall moving faster than the parachutist? So you know that the parachute basically provides a lot more air resistance. So the man in free fall experiences greater air resistance, false. The man in free fall has greater mass, false. The parachutist experiences greater air resistance, true. Parachutist has not reached the terminal velocity. Again, that's not why he is moving faster, right? Why the man in free fall is moving faster than the parachutist. Question number 18, which quantity x is calculated using this equation? So change in velocity over time, this is obviously acceleration. If this was change in displacement over time, this would be velocity. If this was change in momentum over time, this would be force. Displacement is not the change of anything. Question number 19. which chair is the least stable if the child moves? So least stable. So we know that for stability, we look at two things. We look at the position of the center of gravity here, and we look at the base area. So for a very less stable chair, we want the center of gravity to be high and we want the base area to be small. So that's happening in A, where the center of gravity is also high and the base area is very small. So it's really unstable. Question 20. Question number 20. A car accelerates for 10 seconds, then it travels at a constant speed for 20 seconds, and then it comes to rest in 3 seconds. Which graph shows this journey? Again, all of these are speed time graphs. So it accelerates. So I'm looking for a positive gradient at first. Then it travels at a constant speed for 20 seconds. So first 10 seconds must be accelerating, which is the case here, not the case here. So A is out. And it's not been specified what type of acceleration this is. So anything which involves the speed increasing is going to work with me here. So this also seems sort of fine because the speed is increasing up to 10 seconds. Here the speed is increasing up to 10 seconds. And then it travels at constant speed for 20 seconds. So this is out because between 10 and then 20 more seconds, so till 30 seconds, it should have been a horizontal line. So this is also out. And then it travels at constant speed for 20 seconds. So 10 to 30, it must be at constant speed. So this is also out because this does not show that required amount of time, right? It's traveling at a constant speed for 20 more seconds after it has accelerated for the first 10. So the final time we're looking for the end of that horizontal section is 30, not 20, right? It's 20 more seconds. So my answer is B, and it also works with this last part of the description, which is it comes to rest in 3 seconds. So this is a rather sharp deceleration as it comes to rest. So the final speed becomes 0. Question 21. The diagram represents the parts of a power station. What is the order of energy changes taking place? So a coal-fired boiler, and then a turbine, and then an electricity generator. So first off, I know that the end goal of all electricity is electrical energy. So that's happening in all of the options. Then there must be the chemical energy in the coal. So I'm looking for A and B. And first it's converted into heat, and then that steam under high pressure is then basically incident on the turbine, which makes it turn. So it's option A. Center of the sun produces large amounts of energy. What is the source of this energy? So the source of this energy is a nuclear reaction, more precisely known as nuclear fusion, when the hydrogen nuclei in the center of the sun fuse together to produce helium. Question 23 is a rather tricky question, and let me talk about this. So the wheel of a moving car is driven by this engine. The direction of acceleration of the car is shown in the figure. In which direction the frictional force will act on the wheel? Now a lot of you might be tempted to say that just because it's going like this, the friction must be in the opposite direction, but that reasoning is wrong here. Because this is not just moving along it, rather it's rolling along here, right? So it's rotating. So if this is accelerating like this, I know that this tire is going to rotate in a direction like this. And for it to rotate like this, the idea is now imagine that your elbows are this wheel, right? So for you to move forward, let's say if you want to go forward, and let's say you are laying down on the floor and you can only use your elbows to go forward. So at this point, let's say this is the point of the contact of your elbows with the floor. At this point, you are really trying to push the floor backwards so that by Newton's third law, the floor pushes you forwards, right? So in this case, right at this point, let me zoom into this and label some of these forces. This is the frictional force. And again, friction force is just a name for any force which acts between two objects, and there is some relative motion between those two objects. So this is the force in this case which the wheel applies on the road. But this is not what we need here, because we are asking about the direction of the frictional force acting on the wheel. So as a consequence of Newton's third law, the road will apply an equal but an opposite force. So because this was backwards, this is going to be forwards force by the road on the wheel, which is exactly what we need. So in this case, the answer is option D. Question 24, a child slides down a slide. The weight of the child is given. Height of the slide is also given. Work done against friction as the child travels down the slide is 1300 joules. And we know that work done against friction basically takes away energy from our system. What is the change in GPE? What is the final kinetic energy of the child? So when this child descends through all of this height, he is going to lose all of this GPE. So I have the weight. So if I think about the formula, mgh, so I already have mg as 250 and the height is 7, right? So 1750 is going to be my change in GPE, so either A or B. But because there is going to be friction, there is going to be work done against friction, so this is going to be 1750, and the work done against friction is going to take away energy from our system. So whatever remains here, which is really going to be 450, is the final kinetic energy left, right? The work done against friction takes away energy from a system. What uses non-renewable energy? Geothermal is renewable. Nuclear power is not renewable. Solar is renewable. Wind is also renewable. Nuclear does have a lot of advantages, but renewability is not one of them. 26. The diagram shows a girl lifting a box of weight 50 Newton from a low shelf to a high shelf. How much is the work done on the box? So from going from the low to the high shelf, this was 1.8, this is 0.6. So it basically gains a height of 1.2 meters, right? So I have mg again 50 times 1.2, which should be 60 joules, right? Some of you guys might try to do it this way, that you first use mgh for this and then you use mgh for this and then you subtract them, but again it would be the same answer as this. Just think about in this formula, EP equals to mgh. Think about h as the gain or the loss in height. Question 27. A boy who weighs 50 Newton runs up a flight of stairs of 6.5 meters height in 7 seconds. How much power does he develop? So we did a question like this just moments ago. So again, mg is 50, height is 6.5. So this is his energy and divided by time. So I'm really using this formula. Power is energy over time. So 50 times 6.5 over 7. So that's part D. The diagram shows a curved curtain rail that has a steel ball rolling on it. The ball is released at point A. At which point does the ball have maximum kinetic energy? So that would be by the conservation of energy, the point where the potential energy is the lowest, right? That's when the kinetic energy will be the maximum. So lowest potential energy means the lowest height. So that's obviously going to be C. This is exactly like how we talk about a pendulum in motion. It's moving at the greatest speed through the equilibrium position, the lowest position which is. 29, the diagram shows a battery operated motor lifting a block of wood at constant speed. What is the overall energy change taking place? So first off, a battery or fuels in your syllabus has chemical energy. So that's the answer to this one. Only one starts with chemical. And then basically that turns the motor, and the motor turns the pulley and it drives it up. So it causes it to gain GPE. Nothing related to kinetic energy here because there is no change in speed. 30, 4 students exercise in a gym. Which student does the most work? So you have exercise time and power. So here if you want to find work, which is really synonymous to finding the energy, we are looking for power times time. So what we need to do for all of these cases is we need to find the energies for all of them and we need to see which one is the greatest. So that's what the values turn out to be once you calculate for all of these options. Obviously 40,000 is the greatest, so option C is the correct answer. Gas in a sealed container of constant volume. So gas is in a sealed container of constant volume, so volume cannot change. The gas is heated and the pressure of the gas on the walls of the container increases. How do the particles of the gas cause this increase in pressure? The particles individually do not expand. They hit each other more frequently. This is true, but this is not what causes the increase in pressure. They hit the walls of the container more frequently. This is what causes the increase in pressure. And again, they don't really vibrate. We would say particles of a solid vibrate, but particles of a gas do not vibrate. They move faster. Also keep in mind there's a question very similar to this which may be assessed from you guys. And in that question, the setup of the question was the same, but it was asking for what cannot happen, right? So basically you were asked to identify the wrong statement. And you were given some statements as to some particles move faster. So some particles move faster, and then there were more frequent collisions. And these are all the options that I'm writing down here. And harder collisions. And another one was particles move apart. And you had to pick out the wrong statement here. It was exactly the same question as what this is, but the options and what was asked was different. So in this case, the answer is this, because we had to pick out the wrong statement. So this is wrong as a statement because of this reason, that in reality, we know that temperature, an increase in temperature can cause an increase in volume, but because this says constant volume or a rigid container, this means the volume cannot change. So do look out for this when a question like this comes up. 32. Piston is supported by gas trapped in a cylinder. A weight is put on the piston. Volume of the gas supporting the piston decreases, but the temperature is unchanged. What happens to the molecules? Again, you know that as a result of this equation, P1 V1 equals P2 V2, which really shows the inverse proportionality between pressure and volume. So here you can say that the volume is decreasing of the gas, so the pressure must increase. This is because they hit the piston more frequently. They move more slowly or faster, as is the case in D. Both of these are wrong because that just depends on the temperature, which is unchanged here. And particles themselves do not shrink or get bigger. 33. Which statement about thermal radiation is correct? In a vacuum, thermal radiation travels at the speed of light. Again, this is a true statement because thermal radiation is part of the EM spectrum, and all of the what do you call it? All of the components of the EM spectrum travel at the speed of light. Thermal radiation is a longitudinal wave. This is wrong. Again, all EM waves are transverse wave. Thermal radiation travels as a UV. This is wrong. It's infrared. White surfaces are better emitters. Wrong, they are better reflectors. 34. A slice of bread is placed under a red hot electric grill to make toast. How does heat energy reach the bread? Again, you have all of these methods: conduction, convection, and radiation. So you need to think about each of these methods and what can possibly take place. First off, you should ask yourself, can conduction take place here from the grill to the bread if we assume there is air in between? And the answer is probably not, because conduction is very less in air, because air is a poor conductor. Or another way we say this is that it's a good insulator, right? Poor conductor or good insulator means the same thing. Next, we think about whether convection could possibly take place here. Now, with convection, the idea is that the hot air must rise and the cold air must fall in order for the convection current to be set up. But if I think about this here, this right here, the grill is the hot element. When because of it, when the temperature of the air goes up, causing the volume to go up, causing the density to go down, and hence the hot air to rise, this hot air is just going to go up from here. it will never come down and reach the toast, right? So because of this reason, convection can also not take place here. This is the same reason as to why we say that air conditioners are placed near to the ceiling of a room and why heaters are placed near the bottom of the room, right? That's how convection happens. You either heat from the bottom or you cool from the top. So the only one which remains is radiation, and that's what must be taking place here. 35. Two identical metal plates are painted, one white, other black, and both of these are matte, so they are dull. These are placed at equal distances from a radiant heater as shown. Heater is turned on for 5 minutes. Which metal plate absorbs more energy? Which one emits more energy? So you know the rule is that whatever is a good emitter is also a good absorber, and that must be black, which is option A. Fixed mass of gas in a syringe at 0 degrees Celsius is heated at constant pressure. What shows the variation of volume with temperature measured in degrees Celsius, right? So we know that volume and temperature are directly proportional, but only if you're talking about temperature in Kelvin. If you have temperature in degrees Celsius here, so the idea is that 0 Kelvin is negative 273 degrees Celsius. So this graph would actually be correct if this was for Kelvin, right? So just direct proportionality. So volume is proportional to temperature in Kelvin. But if I am talking about this, if this would be 0 Kelvin, then this would be on a graph of temperature in degrees Celsius. This would really be negative 273 degrees Celsius, right? So this is temperature in degrees Celsius. This is your volume in meter cube, let's say. So this graph, which was previously here, this is now going to be taken all the way back, and this is how the graph is going to be. And now if you look at the options, the closest one is obviously B. Thermal energy of 12,000 joules is supplied to a 2 kg mass of copper. Specific heat capacity is given, and you are supposed to find the rise in temperature. So E equals to mc delta T, 12,000 equals to 2, C is 400, and you have delta T. So delta T is just 12,000 over 800. So yeah, 4, 2, 30, so 30 over 2, which is 15 degrees Celsius. Latent heat of a substance increases kinetic energy. Wrong. That's what temperature does. Increases the intermolecular distance. Again, this is true. It does not increase the intermolecular force. It rather overcomes the intermolecular forces of attraction to increase the intermolecular spacing. A saucepan is used to heat up some water. How is heat energy transferred through the aluminum pan and through the plastic handle? So the aluminum pan, because it's a metal, it would be movement of free electrons as well as the vibration of atoms. But we know that what's in majority, what's actually the more dominant method of heat transfer would be free electron movement. And for plastic, because it's a non-metal, it would be vibration of molecules only. So it was this and this, but it can't be free electron movement for the plastic. So it must be just B. A hot liquid is poured into a beaker. So this is liquid when it starts out. This graph shows how the temperature of the liquid changes as it cools towards room temperature. So you have liquid here, then the liquid cools down. This is still a liquid, and the horizontal portion must be showing a state change. Since it's cooling, it must be turning to a solid, and then it becomes all of a solid. What is occurring at the region X? So it's going from a liquid to a solid, so it's freezing, or another term is solidification. But the idea here is that it would also be evaporating, because as long as a state of matter is a liquid, evaporation can happen. Yes, the temperature does affect it, but whatever the temperature is, some evaporation is always happening. So that's it for this one, guys. Hope this helps, and see you in the next one.